Welcome back. So we'll be doing the remaining questions, section B, question number 4 to 6 in this video. So the first question that we have is, we have to find the area of the shaded region, okay? The area of the shaded region in figure 12.3, where we're given radius is 6 centimeter, has been drawn with a vertex of an equilateral triangle of side 12 centimeter, okay? So here when you read the question, the first thing that should come to your mind is, okay, they have given the radius, okay? So radius is given as 6 centimeters, so that means this is the radius of the circle, okay? Even it may not be seen, but we must understand that if we draw another line, this is another circle. This is a circle, right? So this is given as 6 centimeter, which we will be making use of, clear? And what have they given? That they have also given that there is an equilateral triangle O, A and B with sides 12 centimeter each. Okay, this is 12 centimeter each. So that means OA, I'll just write it here. Okay, you have a triangle like this. It's given as O, A and B. They have said OA, okay, is equal to 12 centimeter, which is also equal to OB, and this is equal to AB, because the properties of an equilateral triangle is that all the sides are equal and all the angles are equal. Clear? All the sides are equal, all the angles are equal. So if all the angles are equal, that means all these angles is supposed to be 60 degree each because of the sum angled property, right? The sum angle property of a triangle. Clear? So we're asked to find the area of a shaded region. Now, this is very easy. So we have to find this, okay? So now, in order to find this, we have to find the area of a triangle, yes? And then subtract, what is this here? We have to count the area of a triangle, okay? Then add the area of a rectangle and then subtract it with the area of a sector. You see, okay? We have to count the area of a triangle, okay? Then we need to find out the area of a sector. Clear? Okay? And what happens is, if we take the area of a triangle, okay, and I subtract the sector. So what happens when I subtract the sector from this given diagram? So I'll be left with like this, okay? So see, this is area of a circle minus area of a sector. Then if I take the area of a triangle, then I end up getting this shaded region. Clear? Be careful with that, okay? Because what happens is, if you take area of a circle and add it with the area of a triangle, you will get some extra portions. Clear? That is not what we want. So for area of a shaded, therefore, in the next slide, therefore area of the shaded region is going to be equal to area of a circle. Remember, okay, area of a circle. So you take area of a circle, this whole thing, okay, subtract area of a sector, okay, clear? So we have, okay, so we're subtracting the area of a sector, so it will be something like this, okay. So after that, you'll be left with a graph something like this. This is sector and this is area of a circle, and we have subtracted the sector, okay, plus area of an equilateral triangle. Equilateral triangle. You can name your triangle as OAB. I think that is what is given here, OAB, okay. So see, area of a circle and area of a sector will give you this, but when you add area of a triangle OAB, and this is what you will get, okay? This is going to be OAB, okay? Clear? This is the area of the shaded region. Therefore, area of a circle is pi r square. Area of a sector is theta by 360 pi r square. Area of an equilateral triangle, if you remember, is root 3 by 4 side square, okay? Side square can be written as a square. Now, this is going to be 22 by 7. The radius is given as, the radius of the circle is given as 6 centimeter. So 6 centimeter into 6 centimeter. Now the theta is going to be as 60 degree, because what do we know about this sector? This is 60 degree, okay? Clear? This is 60 degree. So the theta is 60 degree, okay? And why is this 60 degree? Because they have told us that this triangle OAB is an equilateral triangle. Now because it's an equilateral triangle, all the angles will also be equal. So angle O is going to be 60 degree into 22 by 7 into r square is the same thing, which is 6 centimeter into 6 centimeter, plus root 3 by 4. They have given the side of a square to be 12 centimeter. Okay, so 4 into 3, cancel this, cancel 6, cancel this. Okay, so you'll be left with 22 into 36 centimeter square by 7 minus 22 into 6 centimeter square by 7 plus 36 root 3 centimeter square. Okay, so you can calculate this. Okay, clear? So when you calculate this area, you should be getting this as, you take denominator, you'll be getting this as, okay, so 22 into 36 minus 22 into 6, okay, 6 bracket centimeter square plus 36 root 3 centimeter square. Okay, so when you multiply this, subtract this, your answer would be 660 by 7 plus 36 root 3 centimeter square is your answer. Okay, clear? And that is your textbook answer. All right, so now let's go with the next question, which is going to be question number 5. Okay, so for question number 5, they have given the question as, just give me a second. They're given the question as, from each corner of the square of side. So the side of the square is how much? It's 4 centimeter. Okay, they have given this 4 centimeter, 4 centimeter, 4 centimeter. Okay, square has equal sides, so all the sides are 4 centimeter. They have also given that the radius and a quadrant of the circle of radius 1. What is a quadrant? A quadrant is this. Okay, 1/4 of a circle. This is a quadrant. They have given that the radius of this quadrant is 1 centimeter. So all of this is going to be 1 centimeter. This, okay, is 1 centimeter. This is the radius of a quadrant, 1 centimeter. Clear? That's the same thing for all the rest. Now they have given an additional information that also a circle of diameter 2 centimeter is cut as shown. Okay, so they're talking about the diameter of this given circle. Now this is the diameter of the given circle, which is 2 centimeter. Okay, so this is a given circle. A diameter is usually like this, right? A diameter is the point from one end of the circle to the other end, right? So that means if the diameter is 2 centimeter, okay, the radius would be, therefore we can write for the circle with diameter 2, we get, okay, so diameter is given as is equal to 2r. Okay, the diameter of a circle, they have given the diameter to be 2, and this is going to be 2r, so cancelled. So the radius of this circle is also going to be 1 centimeter. Clear? So the radius of this is also going to be 1 centimeter. This is going to be 1 centimeter, 1 centimeter. Clear? Diameter is the entire thing, and then this from the center of the circle to this end is called the radius. Okay, so keep that in mind. So now we're asked to find the area of the shaded portion. Okay, so for this, if you take out the area, and one more thing, you see the sides of each square of this, okay, is going to be 90 degree. Clear? All of this angle, the angle formed by a triangle of a square is always going to be 90 degree. So all of these are 90 degree. Okay, you just keep that in mind. Okay, see, it's two straight line cutting each other like this, so this becomes 90 degree. Okay, or just say the angle or the sides or the angle of each sides of the square is going to be always equal to 90 degree. So these are all 90 degree. Okay, so we have to find this area of the shaded region. Okay, so to find the area of the shaded region, if we take out the area of a circle, area of a square, subtract it with this area of a circle, and then subtract all of this part, we'll get the remaining part, right? So we have a square. If we take the area, okay, I take the area of a circle and I subtract the circle, okay, and then again I subtract this corners of this circle, of this square, then we get the shaded region, right? We get this shaded region which is colored in blue. Clear? Now if you pay attention to this given section, this area, okay, this area, this looks like a sector, okay, it looks like a sector, doesn't it? It looks like a sector, right? See, it looks like this, exactly like this, right? So this is a sector. Clear? And how many sectors do you see? 1, 2, 3, 4. Therefore we can write this way, okay? Therefore area of the shaded region, okay, of the shaded region is going to be equal to area of square minus, okay, see, area of a square, then you have to subtract what? Area of circle, and you have to subtract what else? You have to subtract all this, right? So how many sectors do you see? There are 4 sectors, so you have to write, there are 4, okay, so we have to take 4, 1, 2, 3, 4, 4 sectors, so 4 into area of a sector, okay. So area of a square is going to be side square, which is given as 4 centimeter each. So side square, okay, side square, area of a circle is pi r square, and the area of a sector is pi r square theta by 360, okay. So side square is going to be 4 centimeter into 4 centimeter, or 4 centimeter square. 22 by 7 into the radius is given as 1 centimeter into 1 centimeter. You can cancel out whichever one, okay, try cancelling out. Minus pi is 27. The radius is also 1 centimeter into 1 centimeter. Theta is going to be 90 degree. So you cancel out here, you have another 90, so you can cancel this out, okay. So you'll be left with 4 into 4 is going to be 16, centimeter into centimeter would be centimeter square, 1 into 1 is going to be 1, so 22 by 7, centimeter into centimeter is centimeter square, minus 22 by 7 centimeter square. Now you take the LCM, okay, 7. So 16 into 7 is going to be 112 minus 22 minus 22. So this is going to be equal to, and centimeter square. So this is going to be equal to 112 minus 44 by 7 centimeter square, which is equal to 68 by 7 centimeter square. Okay, this is the answer for question number 5. Now let's move on to the last question. Okay, see, this is an interesting question. We're given, this is the diagram which is given, okay, we're asked to find the design. Clear? So if you really look into it, this is the design, okay, we're asked to find this design, only this design, okay. So how to find out this design is, if we take the area of a circle and subtract it with the area of a triangle, we'll be able to get it. In the question they have given us, in a circular table cover of the radius is given as 32 centimeters. So from this center to this end is 32 centimeter, that is given to us, okay. And what is the triangle of this? This triangle is an equilateral triangle. That means all these sides are going to be equal, that is all of this is going to be 60 degree, okay, 60, 60, okay, and it's an equilateral triangle. Triangle A, B and C is an equilateral triangle. All right, okay. So now we're asked to find only the design. So here we can easily find out the area of a circle, yes, because we already know the radius area of a circle is pi r square. Since we know the radius, we can directly find it out. But we need to find out this equilateral triangle, because they have not given anything about the length of this equilateral triangle. So what we can do is, here if we take a center point O, okay, this is what, from the center to A is the radius, from the center to the point B is also going to be the radius of the circle or not, yes, and from the center O to R to C is also the radius, okay. So we're actually able to divide this given triangle into 3 equal parts. Yes, it's going to be 3 equal parts, yes or not? Think about this. This is the radius of a circle. The radius of a circle, everywhere you take, is going to be the same, okay? So this is, okay, this is going to be the radius of a circle. Apart from that, okay, so this is going to be the radius of a circle. Clear? So we have 3 triangles. Therefore, solution. Okay. Now what is, okay, so we have these 3 circles, now these 3 triangles, okay. So we have triangle OAC, triangle OBC, and triangle OAB. These are the 3 triangles that we have, and if you pay attention to it, this is an isosceles triangle. Why? Because 2 sides of the triangle are same, okay. See, for triangle, let's go with triangle OAC. So we have O, A and C. 2 sides are same because OC is equal to OA. Why? Because they are the radius of a circle, so they are equal. So this is an isosceles triangle. Clear? Now, one more thing is, so this is an isosceles triangle. Let's just remove it. Okay. Now, after this entire angle would be equal to 360 degree. Yes? Okay. It's all 360 degree. Okay. These 3 angles. If you were to add all these 3 angles, you have to get 360 degree. Okay. Therefore, you can always write theta is going to be equal to 360 degree. And how many angles are formed using 360 degree? If you if you add 3 angles, 1, 2, 3 angles, and you get it as 360. So you can cut that, and your theta is going to be equal to 120 degree. Clear? Okay, I'll just show you another way of doing this. So all these angles, okay, is going to be equal to theta, and theta. Okay, these are the angles. Okay, clear? Obviously, so when you add 3 of these angles, okay, theta plus theta plus theta, these 3 angles you must get it as 360 degree. So you take 3, this will be 360, so theta becomes 360 degree. Okay, clear? Therefore, area of the design is going to be equal to, we first have to find, see, we're asked to find the design, so what do we have to find? We first have to find the area of this entire circle. So this is going to be the area of circle minus, we have to subtract this triangle, right? Now, since we do not know anything about the sides of this triangle, which is an equilateral triangle, we do not know, we cannot use equilateral triangle formula because we do not know what the sides are. Okay, the sides AB, BC and AC, nothing is given about it. But there is another formula for this which we have done in exercise 12.2. okay, in case if you are able to draw 3 triangles inside with the center of the circle. Okay, if you draw 3 equal triangles with center as the center of a circle, then there's another formula which you can use, that is r square into sine theta by 2 into sine theta by cos theta by 2. Okay, this is the formula which we have used, but since there are 3 triangles here, we have to multiply it with 3. So area of a circle formula is pi r square minus 3 into r square sine theta by 2 cos theta by 2. Okay, now the next values pi, until and unless it's mentioned, please continue to use 222 by 7 into radius is given as 32 centimeter. Okay, 32 centimeter into 32 centimeter minus 3 into the radius is still the same, so 32 sine theta is given as 120 degree by 2 cos 120 by 2. So this is going to be 260. Okay, so this is going to be equal to 22528 centimeter square by 7 minus yeah, I think that is it, 22 3 into yeah, okay, so that is it. Now 3 into 32 into 32 into sine 60 degree cos 60 degree. Now since you have already touched upon trigonometric values, what is the value of sine 60? Sine 60 is equivalent to root 3 by 2. Yes, okay, and cos 60 is equivalent to 1 by 2. You can always write in bracket Sine 60 degree is equal to root 3 by 2 and cos 60 degree is equal to 1 by 2. Okay, so you can write this. So 2 into 1 and 2 into 2, 2 into 6 is 12, 2 into 1. So this is what you're getting. So 22,528 divided by 7 centimeters square. 16 into 6 into 56 into 3, 768 root 3 centimeters square. Okay, I've forgotten to put here 70 centimeter. Okay, it's supposed to be centimeters. So this is the answer. So you can take 22,528 divided by 7, 768 root 3 inside, and since centimeter square is common to both, we can always take this outside, and it is 22,528 divided by 7 minus 768 root 3 centimeter square. So this is the answer. Okay, we'll do the remaining questions in the next video.